Yeah, hi everybody. I'm pretty happy to be here and to finally meet people in person. It's been quite a long time. So yeah, today I'm going to talk a little bit about our startups, which is developing carbon fiber bipolar plate for heavy mobility industry. So yeah, HYCCO stands for hydrogen carbon components, and we have dedicated our work to a fundamental component which is present in the entire hydrogen chain value. In every system, you do have a bipolar plate, and there are a specific number of issues on the current materials we are trying to solve. Sorry. There we go. So we are a small startup company. We are based in Toulouse, in France, and our team is about 15% right now. So I believe we have produced the first carbon fiber bipolar plate which is available on the market. And as I said, we are trying to solve some of the materials issues that are present. So why the bipolar plate? Well, they are like a major component which is present in all electrochemical systems, from PM fuel cells, but also redox flow batteries or electrolyzers. They are all pretty much made the same, so it's a stacking of two components, the bipolar plate and the MEA, the membrane electrode assembly. So bipolar plates, they play a major role in the weight of the stack, in the cost of the stack, but also into the performance of the system. And if you look at the numbers, like if you take a truck, for instance, 120 kilowatt, you need about 600 plates. So if you want to put 1 million truck on the road, you need 600 million plates. So that's quite a number. And there's definitely a challenge for the hydrogen industry to get ready into delivering so many components. So there's a chance for seeing all those applications being decarbonated. So HYCCO has developed carbon fiber material. As you can see here on the top right, you can see carbon fiber, and it's a mix between thermoplastics and carbon fiber. And you see the carbon fiber is really exposed on the surface, and it brings electrical conductivity from the top surface to the bottom through Z-axis fibers. So the advantage of this kind of technology is that you can get like a very thin. As of today, we are manufacturing 0.38 millimeter thick web thickness, and we are moving to 0.2 millimeter. So basically, we are trying to get the same kind of design of bipolar plates, of metallic bipolar plates, but made of carbon fiber. The advantage is that you save a lot of weight. You increase the lifespan because the thermoplastics are very well known to have very high durability, and this has been proven in the past, and it's present in the literature. We also have a flexible material, so we don't suffer like the graphite of a brittle material that can break when you assemble the stack. And we reach the targets for qualifying our components for hydrogen fuel cells in terms of electrical resistivity, permeability, and temperature. We have started off working on the high temperature PM fuel cells, so our materials that can resist 180 degrees. And by combining that characteristics, we can increase the power density by reducing the weight and as of today, we think we can achieve 4.6 kilowatt per kilo, but by moving to a 0.2 web thickness material, we probably can almost reach the 7 kilowatt per kilo, which is very interesting for heavy mobility applications. So here is a couple of examples of in-situ tests. So on the left part, you see high temperature PM fuel cell aging test over 1,000 hours. And what we have observed is that the only degradation we see is due to the MEA. So this has been confirmed with academic laboratory. So that's pretty interesting. It means our materials are very stable in phosphoric acid. And we also have done some tests on vanadium redox flow batteries, where the material has been cycling in cells for 30 days, either in vanadium redox flow batteries or inorganic electrolyte redox flow batteries. And in both cases, like we've seen, like a very high stability, chemical stability. So we're pretty happy about that. Now, our development roadmap, we are now finishing our prototype production line, and we'll be in capacity to produce about 10,000 bipolar plate a year by the end of this year. And we are moving in a Series A fundraising where we will develop our pilot production line, which is designed to produce 250,000 bipolar plate a year. And then a scale-up will come to go over the million plate a year. So this is really, we believe, what is needed by the industry. We really need to be able to mass produce those components if we want to have a chance to see those technology on the market. So what do? We really go over the entire chain from the plate design. From the plate design, we also do like the mold design, prototype mold design, and we do the manufacturing of the plate. We can do the sealing for prototype, and we have a partner which is developing the mass production of gasket. And we go until the integration into small stack up to 1 kilowatt. And this is mainly done to test in-situ performances of our material, but also degradation test. And that's about it. We're at booth B6210, so feel free to come if you want to have a chat. We'll be very happy to give extra information. Thank you.
Are there any questions from the audience?
My name is Vladislav Tsukunov. I'm a scientist from Russia. And what about your density parameters, yeah, and pressure? Because I think we need to develop more pressure and more density.
I mean, are you talking about like the pressure during stack compression? Yeah, so we've assembled some short stacks, and we haven't seen any issues into the cracking of the plate. It seems to be like mechanically pretty robust.
Maybe one question, a private question to you.
Sure.
What fascinates you most of the bipolar fiber plates?
Sorry,
what's the biggest fascination for you personally?
I don't know. I think it's the core of the system. I mean, you've got the MEA or you've got the bipolar plate, and I was really attracted by this object somehow. There's so many performances that depends on it that, I don't know, I kind of like it.
Okay, I can see it. Thanks a lot. Give him an applause.
Thank you.